Hi everybody, welcome back. This is our weekly screencast on velocity this week, and today we're going to talk about a few things. If you look at our opening slide up at the top here, we have Usain Bolt. He's the fastest man alive. We'll talk about him in a second. Down here in the corner, we have the fastest airplane on the planet. And over here is one of the fastest roller coasters on the planet. It's one of my favorites. This is in Cedar Point in Ohio. At its highest point up here, it's over 400 feet tall. It goes 120 plus miles an hour. And a couple summers ago, I had the pleasure of getting to ride this with my two daughters. So back to Usain Bolt up here. I'm going to show you a little video of when he actually broke the world record. So if we go to full screen here, let's watch.
There is the full lineup. Every single one of the men in this lineup has run 100 meters in less than 10 seconds. Bolt, Gay, Powell, 4, 5 and 6. They're away. Terrific start by Daniel Bailey. Usain Bolt though getting into his running. Here he comes. Usain Bolt challenged by Tyson Gay. Usain Bolt 2 clear meters. Tyson Gay in second place. And in third place is Safa Powell.
9.58! Smashing the world record. Unbelievable! He's done it again!
So there he is, breaking the world record. It's amazing. We're going to come back to that in a second. I just wanted you to see it in action. So our next slide, it's velocity versus speed. Now what I want you to understand is that velocity and speed, a lot of people use them interchangeably, but they're really not the same thing. And if I look up here, under velocity, velocity starts with the letter V. And the way I remember what velocity is that V is it's a vector. And vectors have a quantity like 20 miles per hour or 30 meters per second if we use the metric units, which we should. We don't always do that in the United States. And then over here, but not only does it have that quantity, but it has a direction like east or north. Whereas speed, the key word here, it starts with an S, it is a scalar quantity. That means it just has the quantity. It's just 20 miles per hour, 30 meters per second, something like that, but no direction. Now you're going to think I'm going to cheat later on when I don't give you a direction, but what I want to show you is it's understood that the positive direction is like east or west or north, whatever that is, and the opposite would have a negative value to it. The same thing if I'm going up, that's a positive direction. If I'm going down, that's a negative. So when we talk about acceleration due to gravity that's pulling down, in physics that's usually got a negative number associated with it because of the direction it's going in. So I'm not cheating. I'm just letting you know that is the way they report this. Now if I go to the next slide, what I really want you to understand is velocity is the change in distance divided by the change in time. So if we go back to Usain Bolt as our example, Usain Bolt ran 100 meters in 9.53 seconds. So if I come over here and I pull up my calculator and I go, let's take this over here, 100 divided by 9.53, I get 10.49, okay? 10.49. And what the unit is, 10.49 is meters per second. And what that means is that for every second, he ran 10.49 meters. Okay? So that is how you figure out velocity. It's distance divided by time, or the change in distance divided by the change in time. So he went 100 meters, 9.53 seconds. I divide them, and I get 10.49 meters per second. So every second, he went 10.49 meters. Now what that means is, if I go to the next slide, this is about ratios and proportions. All right? And so, in math class, in 7th grade math, you're going to do a lot with ratios and proportions. And so if I'm looking at 10.49 0.49 meters per second. That per usually means divided by. It's that divided, so it's meters per second. For every second, I go 10.49 meters. If I say that I can eat 20 hot dogs per minute, that is, I can do 20 hot dogs eating for every 1 minute. So later on, we're going to figure out how many I could eat if I did this for 5 minutes or 10 minutes. Okay, so this is just a ratio, and we're going to solve problems with that ratio. Okay, so here's our first problem. I'm going to read it to you, and then what I want you to do is stop and see if you can solve this. Okay, problem 1, Mrs. Hislop drove Tony Stewart's car. She's a big fan. She somehow got into NASCAR in one of the races. She stole his car. She drove it 500 miles over 3 hours before the police finally caught up to her. It's like Grand Theft Auto on a big scale. Mrs. Hislop is pretty hardcore. You just don't know it. The police caught her after 3 hours. We want to know what her velocity is in miles per hour. So stop and try to do this. Okay, here we go. Velocity equals distance divided by time. I have a distance here of 500 miles and a time of 3 hours. So I take 500 divided by 3, okay, then I get, let me go back here, to my calculator. If I take 500 divided by 3, I get 166.7. We'll round it. All right. So that equals 166.7 miles per hour. So that means for every hour she drove 166.7 miles. That's the ratio. Okay. Let's go to the next slide. Problem 2. Mrs. Griffin was flying her broom in a game of Muggle Quidditch at a rate of 80 miles per hour. How far did she fly if she flew 4 hours? It's a little bit different. I want you to stop and try to solve this. Okay, we're back. Remember, velocity equals distance over time. But this time they didn't give me the distance. They gave me the velocity. So that velocity was 80 miles per hour. And I don't know distance, but I know time, 4 hours. So to solve this, I cross multiply. 80 times 4 equals D. So if I go back here to the calculator, clear it, 80 times 4, sorry, times 4 equals 320. So my answer, the distance is 320 miles per hour, and hours are our units, so it'll be 320 miles. That's how far she would fly. So if I'm given a velocity and time, I multiply them together. V times t equals d times 1, and I get d that way. All right, one more problem. Question 3. Mr. Durham can eat 3 cheeseburgers per minute. How long will it take him to eat 21 cheeseburgers. Okay, so let's look at this. Again, we'll go back to our formula. Velocity equals distance over time. In this case, it's not distance. It's going to be the rate of cheeseburgers. Okay, so the velocity is 3 cheeseburgers per 1 minute. Okay, how long will it take him to eat 21 cheeseburgers? So the time is what we're looking for, and he did 21 cheeseburgers. So we're looking for time here. So 3 times t equals 21 times 1. Divide both sides by 3. And time equals 21 divided by 3, 7, and the unit is minutes, 7 minutes, which makes sense because if he can eat 3 cheeseburgers per minute, to eat 21 cheeseburgers, it should take him 7 minutes. Okay, plugging it into the formula. Okay, last word that I'm going to have on this topic is I want you to look at this final slide. A lot of times we graph these, and when you have distance on the y-axis and time on the x-axis, and usually when we're working with time, it's on the x-axis. If you get a curved line like this on a free-falling object, it's speeding up. That's called acceleration, and we're going to talk about that later in our next video. Acceleration will be in there. If we get a curved line. However, if the line is just a straight line, it's not curved, it's a constant velocity. Now, if the straight line's like this, that shows a velocity. But if the straight line is like this, the slope of the line is steeper. The steeper that slope, the faster it's going. If the slope of the line's like this, that's slow. It's a little bit faster, and that's still faster. The steeper the slope, the faster it goes. That's all we're going to do today. We're going to practice some problems in class. You got a quiz on this on Monday, and we're going to do 2 labs. So I hope that you've enjoyed the video, and we will talk about this later. Until next time, thanks.